Hello, my name is Victoria Kickham, and I am a senior editor with DC Velocity magazine. I'm here at Modex, and I am with Saif Sabti. He is Vice President of Sales and Operations with SSI Schaefer, and we're here to talk about robotics and automation.
Hey, Victoria, how are you?
I'm fine, thanks. Nice to be with you.
Thank you for having me.
No, pleasure.
It's a pleasure to be at Modex. I think we have an interesting topic to talk about.
Absolutely.
The show is really all about robotics, and we're going to take a couple of minutes to dive into robotic piece picking and also case picking, which is really a big ROI drivers in our industry.
Absolutely. Let's get to it.
Okay, so to really introduce the topic of robotics, we're going to look at a real world scenario, and sometimes to introduce a complex problem like robotics, it's good to see how it would be applied to a solution. So in this case, we looked at a pharmacy retailer that is struggling to fulfill orders. They have some of the typical challenges that many retailers are dealing with, which is order accuracy, labor scarcity. But on top of those challenges that everybody in the e-com and fulfillment world is dealing with, they deal with regulatory requirements for order tracking and traceability. So they came to us wanting to understand how would robotic piece picking and robotics in general can alleviate some of these pressures combined with an automated storage and retrieval system. So what we've essentially done during the design of the process is to sort of say, okay, let's not look at the problem from an equipment perspective. Let's look at the solution as a whole. And let's look at the entire process from receiving the products into the building all the way to outbound, instead of just focusing and segregating that robotic piece picking element. So we looked at the receiving process and we realized that the customer is receiving products on pallets. And we said, okay, what is the most efficient way to depalletize this product? Of course, robotic depalletizing has been around for a long time. It's not a new technology, but mixed SKU depalletizing is somewhat relatively new. Pallets arrive with different size cases. Layers are not unified, so you may have a layer of 10 cases and the following layer may have, let's say, 8 cases of a different size and a different weight. The order handshake or the handshake of data between systems does not always have clean data, so you really need to rely on both data that you're receiving from the host system, but also vision system that recognizes the cases per layer and essentially instructs the robot to depalletize the layer from the depalletize all the cases onto a conveyor to be put into an ASRS. So the first part of the system was to essentially implement a mixed SKU vision enabled depalletizing robot. So with that, we've essentially taken the receiving process and made it more efficient through robotics. And then we said, okay, let's follow this process forward. What happens after the cases have been inducted into an ASRS system? So we said, okay, wait for the video to load. So what you'll see here is essentially orders being picked automatically with a piece picking robot. And typically a piece picking robot is fed through an automated ASRS system. Piece picking robots have came a long way in the last 5 years, and it's really driven by developments into vision software and also camera hardware, right? If you look at our phones and mobile devices over the years, camera hardware and camera modules have gotten better, have gotten less expensive, and also the software that runs them has gotten better at recognizing objects. So the whole machine learning AI behind it has improved, and this is something that we can leverage in our industry and essentially enable applications that maybe 10 years ago weren't possible. So our piece picking robots really pick items reliably, but we also don't rely on piece picking robots for 100% of the SKUs. We do realize that humans, in certain cases, are much more effective at picking items than robots. And we try to create those sort of advantages and disadvantages between human picking or robotic picking into those applications where we say, look, those applications are perfect for a robot, and those applications may be better picked by a human. And we also do time studies to sort of say which method of picking realizes the best ROI. At the end of the day, it's really a balance of ROI versus, let's say, a reliable technology. We don't always go after, hey, it's a flashy robot, let's do it. Well, at the end of the day, it needs to have a positive ROI. So really with that, we combined multiple technologies. We combined an automatic A-frame picking for that type of solution, and A-frame pickings have been really around for I'd say over 10 years. It's not a new technology. It's very reliable for a subset of these SKUs. So we combine A-frame picking, we combine robotic piece picking, and we combine goods-to-person human picking. And our software that looks on top of all these modules looks at the orders and say, okay, what is the most effective and efficient way to pick that specific order, and then releases that order to a specific area. Now, an order may be picked into multiple areas. So, you could pick 3 items into that zone and then it goes to another zone. But the software system looks at it from an efficiency perspective and sends it to these specific areas to be picked in the most probable way. And this is how we build robustness into the system, because you're not trying to make something do something that it's not naturally good at. So that's really in our approach. And robotics is a big field. With our piece picking robots, visions improve and we're able to pick more items as time progresses. And this is why we combine human picking and robotic picking with the idea of as our vision algorithms improve, we get to shift more to the robotic piece picking and take away from the human picking, but we also leverage human picking in areas where it's very effective and efficient.
Yeah, I like the way you described the project, how it involves all of those elements. And I wanted to ask, are you starting to see more applications requesting robotics, specifically the piece picking part of it?
Yeah, really good question. I would say yes, but also not only piece picking. We sometimes forget about robotic case picking. So if you think of grocery, for example, a lot of what ends up being delivered to a retailer or a grocery store is a case quantity. And robotic case picking is very popular, which is the process of taking a single SKU pallet and creating a multiple SKU pallet out of it. So that is also on the rise. But also inherently, layer picking is on the rise. So historically, we used to build these one pallet in, one pallet out type solutions with a high density ASRS. Now customers want us to implement robotic layer picking, where you're essentially building these rainbow style pallets, they call them, where you have sort of multiple layers of different SKUs. And also robotic piece picking. Robotic piece picking, with advancements in hardware, with advancements in robotics, and so the cost of robotics, vision, and computing becoming much more competitive than what it was 5-10 years ago. These applications are having a better ROI than ever used to, and they'll continue to improve.
When we think about labor savings, how much labor savings are companies really getting when you're talking about all of these kinds of implementations?
Yeah, so we measure the projects by ROI, and sometimes customers that are entering into the world of automated logistics ask, do these projects have ROI? And the answer is they absolutely always do. Otherwise, we wouldn't execute any of these projects if there wasn't an ROI. So the savings really relate back to ROI. ROI really ranges as low as 2. Sometimes it goes up to 6-7 years. The savings on labor depends on the amount of shifts, the type of orders that are picked. So it's really hard to put a number or a percentage around it. We typically measure it in returns on investment for a project, and that's sort of the range I provided. But we look at every project, we try to say, how do we automate the most with the best possible ROI case?
Thank you. What about the use of cobots? How have they affected productivity in distribution facilities, fulfillment centers?
Yeah, so definitely cobot use is on the rise. We see them more in manufacturing than necessarily logistics. They're used quite often in demo purposes because you can put them on a trade show floor. If you walk around Modex, you'll see a lot of cobots because you basically don't need to put a fence around it. They basically have a very low risk factor, allowing you to get away with not having guarding or fencing around them. So for show purposes, they're really good. When they're working side by side with a human, they're really good. But if you're trying to get high performance, really high velocity, still your conventional robots are significantly faster and also have significantly less service requirement than cobots. So we still use both. Cobots are getting there. They're faster every year. They're more, let's say they have a longer service life every year. But in high throughput applications, conventional robots still have a place.
So it all depends on the project, yeah, and the application. How has warehouse software improved to better interface with and manage these robotic technologies?
Yeah, I mean, software is getting more complex. Historically, we would start the project design looking at automated storage retrieval systems, looking at conveyors. It used to be that we would put the layout together, the mechanical layout together, and then sort of say, okay, what software do we need to run this equipment? This is how design used to be maybe 5 years ago. Now we're actually starting to look at the software first and sort of say, okay, what improvements can the software bring? And then really walk the customer journey from the software side to figure out how software can control all of these different elements. But definitely software complexity is going up. But what we're also now looking into, just beyond software complexity, we want to look at software usability. So we always looked at the features of a software, and we try to add more and more features to make the software more robust. But what we also now try to keep in mind is the software usability. How intuitive is this software to use for the end users? I mean, we look at our customers' perspective and we say, well, our customers are struggling to get labor. They have high labor attrition. They can't really train warehouse employees on a piece of software that requires 2-3 weeks of training. They want their employees to look at our software and maybe within 30 minutes, they know how to use it, maybe within an hour. And now we're looking at our UI design and UX design and trying to say, how do we make this as intuitive as possible? The simple example is we move more towards icons than towards text and menus to make it more intuitive and make it more user-friendly for warehouse staff.
That makes a ton of sense, absolutely. Where do you see the future of all of this robotic technology heading? And do you think we'll ever get to a dark store concept or dark fulfillment center?
Yeah, maybe a couple of years ago, this was a really nice buzzword.
Yeah.
But if you look at the adjacent industry and sort of the autonomous space, which is the whole autonomous vehicle space, the autonomous vehicle space is enabling battery density to go up. So now you can pack more energy per square inch into batteries, so robots can go longer. Cameras are becoming better and cheaper, and also processing power is becoming better and cheaper. So the whole development that's enabling the autonomous vehicle is really spilling into our space. And you think about it, a lot of these technologies are very similar. I mean, you are moving a bot into a 2D or a 3D world. That's very similar to the development of autonomous driving. A lot of these warehouse robots are now going away from the planned path, which historically was AGVs. So you have a path that is planned, and if something gets into your way, you're stopped as an AGV and you're waiting for a person to move that obstacle. Well, the new generation of bots adapt to this situation. So if say, okay, I'm trying to get from point A to point B, this obstacle is in my way, I can navigate around it. And these are all things that are going to continue to develop because of other technologies. And I think more and more warehouses will have fewer people. And now with labor shortages and the constraints that customers have with labor, there is a big drive to really automate as much as possible. The technology is getting there. I think the business demand is pushing it. And I think we're not far away from having essentially the magical dark store.
That would be very interesting, and we're certainly seeing a lot of these advances that you're talking about too. Anything else you wanted to share, either about the project you discussed earlier or anything else about the future of this technology?
Yeah, I would say it's a really exciting field. Um, you know, every time we come to the show, we're surprised by, let's say, the level of participation and also the level of innovation that's coming out of our industry. Software is definitely is the sort of distinguishing factor, and as hardware capabilities become maximized, companies distinguish themselves through software. So we're seeing a lot of that. But really, really exciting industry, tremendous growth across all verticals, and we're just happy to be in it.
Yeah, and the interest is certainly there. This is a busy show here. So, Saif Sabti of SSI Schaefer, thank you so much for being with us.
Thank you. It was my pleasure.
Okay, and have a great day.